Hello, thanks, kitten. Hello, Skylias. Welcome to the CosmoQuest X Hangoutathon 2020. How are you doing?
I'm good, and thank you for having me.
I just realized we're having a conservation of Colorado at the moment because we had Phil Plate in the last segment. Ms. Brick Kitten is in Colorado. You are in Colorado. And I'm pleased to say none of you have been coughing. I'm hoping that you're doing okay enough with all the smoke up there.
Yeah. So far so good. It's irritating just naturally, but I believe Phil and I are I think he's a little bit north of me. But yeah, we've been close to the one of the latest, well not the latest, the East Troublesome fire is actually not as close as the oh gosh, I'm forgetting the name of it. There was another fire that was, approximately about 10 miles away, and that
Oh,
happened last week.
geez.
But that one seems like it's doing better. We're more worried about the Cameron Peak fire and the East Troublesome because those are surrounding Estes Park right now, which is not
Yeah.
good.
And this is where sometimes it is so good to escape the world we live in and
Yes.
go to a different world instead. And you're actually the one that introduced me to some software that allows us to basically punish our solar system because sometimes this is what we need to do. Maybe no more often than here in 2020. And what software is that? And can you go ahead and share it to me over in Discord?
Oh, yes, absolutely. Let's see. And then
Oh,
hopefully, does that work?
it will in a moment. Hold on.
Okay.
So many buttons. So many buttons. It's not. There we go. All right. I just need to pop out this video and then I will have us over on the other screen.
And just a small correction. So the punishing one, that would be Universe Sandbox Squared, which is also a great, that's the one where you can do all kinds of physics fun, crashing moons together or turning Jupiter into an actual star.
As one
Um,
does. As
mm-hmm.
one does.
Yeah, that's a different one. This one's different, but I like both of them for completely different reasons. This one's one where you can go and see either procedural objects or you can also explore things that we do know. The devs of this team are absolutely amazing. They started off, just working amongst themselves. And it turned out that, they were able to actually get something going and now it's available on Steam. So um, this has actually been years in the making. I think they started around 2005, I think. I could be off on
Wow.
that. It might be 2002. I think it's
So
2005 though.
I almost have it lined up. Sorry, this is real
Oh, it's
time
okay.
production taking place.
I understand it fully.
Yeah, so Skylias and I know each other thanks to TwitchCon. When I was just a baby streamer, she and I met during a session on basically communicating space through Twitch. And we've been friends and helped each other out pretty much ever since then.
Yeah. Yep. That was in 2018.
And here we are, 2020 for the flail, and we're still doing what we do.
Mm-hmm.
And I almost have my screen rearranged. So we have your screen up. I don't know if you're watching the stream and can see what we have. I'm still rearranging a few things, but we're 90% of the way there. So currently we're looking at a stunning planetary nebula.
Now you're seeing me change all of this. Hold on, I can change it to full screen real quick here.
It's all good. It's all good.
So there you go. So you don't have to see. Yeah. So this is a diffuse nebula. This is one that these are. Oh wait, I'm going very very fast. So you can go at pretty decent speeds here. But yeah, it's just I think it's just a beautiful one that they have. working on these kind of details within the nebulae in this game is something that they've worked a lot on. It's actually really nice when you can adjust things like for this one, for instance, would be the bloom. So the bloom's really going to bring that out more in this case. So you can see that how much more color you get with the bloom being exaggerated quite a bit there. But isn't that lovely?
That's gorgeous. And this is based on real data where folks have carefully teased things apart to understand the three-dimensional reality of what we see in two-dimensional images.
Yeah, I mean, they have some procedural stuff, but that's also still taken from information that people like yourself, like planetary scientists, know. This is actually pooled. They take stuff to expand the content, but based on information and probabilities, especially with their exoplanets. And so what's really cool about this is that you can actually target, say, one of these stars. So we have a white main sequence binary, and you can go to this star and you can look at the potential. So this is where some procedural can come in, but as we know, the likelihood of there being planets around stars are pretty good in general, dependent upon the star and the distance. But in terms of like habitability, that's a whole nother story. But you can get closer and actually expand. And so as you see here, these would be the planets within that, and it's right above my head. And there's another way you can even look at it, and that's through something like this. So showing the binary stars there, and seeing, the planets up closer here, as you can see. So that's a cool way that you can I haven't done this much on my own stream, but it's super interesting, especially if you just go to one of these items. Like this one looks pretty interesting right there. Is it going to let me select it? Yes. So here would be one, and I would turn down the bloom significantly now that we're not looking at the nebula itself. So I do a lot of these kind of adjustments on the go, just so you can get you can start seeing rings, and certain angles, you can see those rings. So pretty cool stuff. This is like just one of the things that they have. They have a bunch of just eye candy of some of these. So Titan's shadow on the rings of Saturn, or Titan on the, yeah, I said that right. Brain's working just fine today. So you can see that here. Isn't that cool?
Yeah.
It's pretty impressive. And it's a good way to also show kind of moons of our planets in our own solar system here and how they move. So you can show that. You can also scare people with the amount of the mini moons, the moonlets, and freak people out over that. I like to do that often, because then they just get super surprised when they see this, as far as the Saturnian system goes.
That's amazing. I've never seen that before. It looks like the bird's nest in China or something.
Yeah, yeah. Or a lot of people say it looks like spaghetti.
That too. That
That
too.
too. Yeah, and you can do that. So you can search over here. So you can just search Jupiter. It's another one. But I think, is Saturn still leading with all of the moons? I mean, last we heard, right? In the terms of number
I
of
can't
moons.
keep track
I
anymore.
know, I know. It changes so often. But
Oh
yeah,
wow.
there's Jupiter's system in full. So this stuff's really, really cool. So you can, obviously take away this clutter to reduce any kind of noise there. But then you can get in closer to Jupiter. But I'm going super fast again, and I've sped up time. Wow. Okay, so I lost Jupiter. Jupiter's gone. There it is. So I've sped up time quite substantially. But it's also great for showing, stars orbiting our supermassive black hole too. That's a good way of showcasing
Yes.
some of the work that Dr. Andrea Getz and her team has done, with like tracking the movement at SO2.
Yes.
And actually, I would flip this. So, but look at how pretty this is and the detail that they got with Jupiter.
It's just gorgeous.
See that?
Yeah, that looks like Juno data.
Mm-hmm. Yeah. Just capturing all those storms. Um, and then the
All
one
right,
that
Minecrafters, reproduce that.
here you go. Easy.
Let's do
No
that
big
in
deal.
8-bit. And Adam, altogether, thank you so much for your countdown to donate. Pixel Riff just wrote in the comments, I'm trying my best over here.
And the one I was telling you about,
Yeah.
the New Horizons one, because I've done this one quite a bit before they even put this in here, because showcasing this has been really cool. So I have to manually adjust the speed again, but this is really impressive. So this is the backlit image that New Horizons was able to take that showed us so much about Pluto.
That atmosphere.
I know. And then you can get a little bit closer and you can even land. And
Which is
now I'm
better
on
than we can
Pluto.
do with the actual Pluto.
All
And
right, now
and
I'm
I'm
there.
glad you mentioned Pluto because during our next session we are going to be joined by Dr. Phil Metzger, Charles Dietelick, and Mark Sykes, and we're going to be talking about what is and is not a planet, looking at it both historically and as the IAU changed it and as people would like to change it back. What side of the Pluto debate do you come down on?
I always say it's still a planet. It just has more friends now that make more sense for it, you know? It just found a better group to hang out with. So it's still a planet. It's just a dwarf planet.
See, if we're going to make Pluto a planet, I am team Ceres,
Uh-huh. Oh,
and you
absolutely.
have to make Ceres a planet
Yeah.
again. As long as
Yeah.
Ceres is allowed to be a planet again, I'm good with Pluto being a planet. But until Ceres can be a planet, all bets are off.
Yeah. And look at this. I mean, so this is actually using, and I agree. I agree. Series has to be counted in there. So you'll see parts that aren't mapped, and that's because we didn't map them.
Yeah.
So that's an aspect I actually really enjoy. Some people are like, why is it just not all completely filled out? Well, because this is actual science. And actual science didn't get that side. But we did get all of this lovely. Look at all that right
Yeah,
there.
that's just the colors of it are what always get me.
I know. It turned out being like this was just shocking. I remember when this whole event happened. I think everybody's jaws dropped, but we can go to Sirius too to make the argument. I mean, Sirius is serious.
And for those of you who, like me, are Team Ceres, we do have a shirt up on our Redbubble store that says Ceres, the other former planet.
That's awesome that you have that.
I've got a rep for my world.
Yeah, yeah. So there's a lot of content like this. Like one of my favorite things to show people is J1047B. So it's not going to actually do B. I'll just have to go to the host star because B is,
Yeah.
you know. But I mean, even looking at the detail of a star
They've got
is pretty
star
cool.
spots.
Mm-hmm. They do. When I get closer, it's obviously going to get brighter. But yeah, they've done a pretty good job with this stuff. So obviously it takes a second to render. I need a better GPU too, even though I'm running a pretty decent GPU. I gotta compensate for Space Engine, but um a lot of people can still run this, but it is demanding. I used to be able to run it from my old Alienware laptop. I don't think I'd be able to do that anymore. But they do have this for VR as well, and I've tested it
Oh,
in VR,
wow.
and it's yeah, it's another level of amazing. So this is, do you remember this one? This big exoplanet. Well, it's not big. It's actually its rings are just insane.
Yeah.
Um, it's about 420 light years away from us. But yeah, they found this through the transit method, and you can see how they were able to find out how big its rings were by the star's light passing through each of these rings. And obviously, it being symmetrical on both sides. But this puts Saturn to shame.
Yeah,
This
yeah.
planet is a Saturn shamer.
Now we don't like to shame any world,
No, no,
but
no, no. Saturn
it
is amazing.
in the competition of did they put a ring around it, this one won.
Right. So I've been asked this several times. What are your thoughts on how a ring system like this could form? And such a robust ring system.
It really feels like they must have, as a system, had an encounter with some other disk. I can't figure out how this happens
Yeah.
in a planet forming nebula, a star forming nebula. That protoplanetary disk just seems like it would have stripped all that material off. But
Right.
if there was some sort of a catastrophic event as things passed together and new material could be drawn in, either that or it had to be two massive worlds that collided in a shattering way, but retained enough gravitational pull that a new world emerged in the center. And we're seeing this fairly recently after the event, and things haven't had a chance to settle back out because the furthest out objects on that are just barely held on to gravitationally. And
Right.
over time, they're going to get pulled off. But that's me, an astrophysicist who studied variable stars, um, giving my best guess to how that could happen.
And I finally did get that shot. Now you can see how the star is passing through those rings,
Yeah.
which is pretty impressive. So let's see. There's other ones too. So I can show a black hole. I can do Sagittarius A star. We could do our own
Sadly, we won't
supermassive.
get the Nobel Prize,
No, we will not.
but our
Nope.
observations will be satisfying.
So as you can see, they are showing this more as it being an AGN, right?
We are not, we have a
We are
slow
not.
rotating black hole.
Yeah, we don't have these lovely jets. I don't believe. I don't
We do
think. I
not.
think we're on a diet right now, right?
Yeah, we have sad little X-ray remnant bubbles from when our supermassive black hole has occasionally burped in the past, and there's new papers published just this week showing that because our supermassive black hole is rather slow in its rotation, it won't have amazing jets, even if it does someday become a quasar in the future.
Mm. And you can see the. Do you see the lensing effect that I have here,
Yeah, that's
which
cool.
is super impressive? That's dogs.
Yeah, they happen.
Um, they do. But here's those stars. So this is another great way to kind of showcase um, when people say, "Well, how do we know that we have a black hole? What's the proof?" And then you can do something like this, which
Yeah.
shows all of those stars moving around, and I can even reduce the orbit. So, but you can see that right there.
That's
And
amazing.
SO2 is going around really fast in there. So we always try to find SO2. It's kind of a fun game with my. It's in there. And if I take away the orbits, it's probably going to be easier to see.
Yeah.
But yeah, and this is just so. Oh, there's SO2 right there. Ah, we target it. We got it. So there's
And
SO2.
what I love about the observations done by Reinheld's team and Andrea's team are that they were able to capture back in the 90s when they started their study one of those stars zipping by on its closest approach to the supermassive black hole. And it was that zip as it went past
Mm-hmm.
at the closest point that allowed them to say, yes, confined within this little tiny radius, there must be a mass that can only be explained as a black hole. And while there's often a star, you can see them, they just zip past and then appear to get flung out to the further parts of their orbit. There isn't always one in there.
Mm-hmm.
And so they developed the right technology at the right time to answer the right problem.
Yeah, I think SO2 when it gets closest gets speeds I think of like roughly what was it like 2.8% the speed of light.
That's what I remember as well.
Yeah, which is ridiculous. That's insane. But so cool. It's I mean again just seeing this and being able to visually demonstrate this is really cool. A good black hole that doesn't have jets that we can look at without the jets would be trying to think of we could do the monster one. We could do IC 1101. Um which is it's not even showing up here. Am I doing this wrong? IC 11 or wait, oh I have to do a space 1101. There we go. So this one and usually if this is obviously a much older galaxy,
Yeah.
pretty gas poor. But
Red and dead is how
yes,
we often refer to it.
but very, very, very big, very big. And so its supermassive black hole is going to correspond to the galaxy size. So we're going to fall in for a second. It's going to go. It's going to we're going to it's going
Whoa.
to see, and then we're inside of it now. So then I have to crawl out of it, going insane like speeds here, not temperatures, speeds. So this is what we end up with. And this is a much better, and it's even lensing the name of the stars around it, as you can see. But how cool is this?
That is cool. And that's light getting bent by gravity.
And you can see this whole shot too. I love that the numbers. I'm going to leave them up because it's just great. The numbers are even bent by gravity. See that?
It's hard to see. I don't think the audience can see it because of how it's shown on the screen to allow both of us to be seen as well.
Oh, yeah, because there's definitely some lensing happening, which is the
There
number.
is they are gravitationally lensing the numbers.
It's so good though. So good. But yeah, this is I mean, if I even turned just the brightness of it that you can see the sheer size of it. It's huge. I forget how big this one is. People can probably go and look that up. And we probably have estimates, probably nothing exact, but yeah. So this one's a real cool one. Is there anything you want me to look at in particular?
So let's see what would be cool.
I have the pillars of creation.
Oh, I'm going through my head some of the recent discoveries. We might as well go to the pillars of creation. They're pretty darn cool.
Mm-hmm.
This is a star forming region. If you're using a regular telescope, you can see the Eagle Nebula, and the pillars of creation are part of that Eagle Nebula.
You can see it right there.
And while we're pulling this up, I'm going to go ahead and do a station identification. My name is Dr. Pamela Gay, and I am here with Skylias, a science communicator here on twitch.tv. We are on twitch.tv/CosmoQuestX and Now Media Radio, going out on the airwaves and Apple TV and Roku. Um, we are here to raise money for CosmoQuest and our continuing science education, and citizen science efforts. We have a small staff, a lot of part-time people. We offer everyone who needs it medical benefits. It takes money to do everything that we do, the Daily Space, Astronomy Cast, all of our rocket launch streams, and we're asking for your help. And I understand a lot of you can't help right now because plague times. But if you're one of the people that actually has the reference frame to look at your retirement accounts and understand the stock market doesn't suck right now for reasons I cannot explain, if you could consider donating, we can only do what we do when you are able to help us out. So thank you. And Thank you. I see that Andrew Y just tipped 72.99. Thank
Nice.
you so much. Thank you. Hey Rex, welcome to the chat. Um, thank you.
Skynet, you're hearing this too. If anybody's in here and can help, it'd be greatly appreciated. It's a wonderful team.
We're just
Support science, please. Please. And the
and
people that
we're going
help
to
do
do
it.
what we can to keep bringing the science. And what I love about working with you, Skylias, is you and I come from this from opposite sides because I am an astrophysicist who spends most of my day doing software work. That is actually what pays the majority of my bills. Is I do scientific support on the software side of things at the Planetary Science Institute, as well as the work we do here at CosmoQuest. You're a computer scientist who does science communications, and you can rattle off galaxies way better than I can most days.
That's just because it's so much repetition, day in and day out.
And
But yeah,
but this goes to show that it's that 10,000 hours thing.
yeah.
You have put the 10,000, you've probably put way more than that in just on Twitch at this point,
Hmm.
and have mastered the ability to bring us things like this. And this is an amazing. What star cluster have you brought us to?
This is the NGC 869. It's the Open Star Cluster, Cluster H. Persei? I don't know. I
Percy.
don't know it by that. Percy. I was going to say I only know it by its NGC personally. But yeah, this is, and I think Andromeda's creeping behind. I think Andromeda's photobombing. It is. It is totally photobombed. Andromeda does this all the time when I'm in here. It just likes to show up. But yeah, I only know. It's funny. I only know this. Well, what do you know about this open cluster? Obviously, open clusters are different than
I
globular,
only know about open
closed.
clusters as a group. What's this NGC number again?
NGC, what was it? Let's see. It was NGC. Oh, it's going to just target the stars now. Where is my info on it? Hello. Let's see. 869.
Yeah, I don't know this one. There's a few open clusters I know because they're extremely well mapped, and I use their stars as comparison stars in research.
Right?
But
Yeah.
this one is apparently not near enough anything that I've studied that I've needed to abuse it.
Here's where we'll wow everybody though, because these clusters, as you know, they usually can be wrapped within in the galaxy, but usually they're kind of going above or below. Globular clusters definitely are up here, as you can see. But yeah, this is where this we're going to a new level with this. So I'm going to actually reduce the bloom so everybody can see this.
Did you
Um,
hear about the globular cluster that was super metal poor that was just
yes,
randomly found?
yes, yes,
So tell
yes.
our audience because this is a story, and you're talking about Andromeda always creeping on things. Relay the story.
Yeah, so the if it's metal poor, that's going to mean that it's pretty old.
Yeah.
So, I mean, I read about it, but I didn't go far into it. I didn't stream about it yet. But I only just read that it was a metal poor globular cluster found. That was all I read, but I know metal poor would be indicative of being older. So, meaning that those stars within that cluster don't have high levels of metallicity, things that usually occur in further populations of stars. So these would be old stars.
And what was so weird about this system is globular clusters are always filled in our galaxy. We found a few young ones out there, but in our galaxy, they're all old. They're all metal poor. But
Hmm.
they were only so metal poor, and we thought there was a floor beneath which the universe just wasn't ready to form globular clusters. So early on, everything in the universe was hydrogen and helium, trace amounts of lithium and beryllium.
Lithium.
And the first few generations of stars had to live and die and give up their metals to the rest of space
Mm-hmm.
before our globular clusters started to form. And the assumption was that below a certain point, the physical shocks, the physical density structures The things that have to happen to slam gas and dust together, concentrated enough to form tightly packed stars as they are in globular clusters. We thought that that could only happen after a certain period of time had elapsed. And there was a astronomer up at, I forget which Hawaiian observatory it was, and they'd been allocated a certain number of hours, and there was assumptions that it would take a certain amount of time to slew, to focus, to do all this maintenance between images. And they blew through all of their intended targets and still had some time left in the evening. So they pointed at a globular cluster in Andromeda, because Andromeda is always there. And
It was Keck.
it was Keck. Awesome.
Mm-hmm.
So they were using Keck, and they found a globular cluster that was 800 times less metals than our sun,
Yeah.
and several times less metal rich than the globular clusters in our galaxy, and we have no idea how this happened. And I love it when we have no idea how something happened.
Yeah, it says right here, the stars in the cluster called RBC, and then that's the first part of it, EXT8. So they used the Canada, France, Hawaii telescope, and then they used Keck. On average, 800 times less iron than our own sun, and are 3 times more iron poor than the previous globular cluster record holder. It's also extremely deficient in magnesium as well.
And so the universe has again showed us it's more creative than we are.
Yeah, over and over and over again.
This is true.
This is so true. So this is another great way to show the Milky Way. You can actually go and see. Now this does have some procedural information on this. I'm trying to see if this will even work though. It will. When I like to blow people's minds with showing just the scale of things. This one's always a good way, because even though it might have procedural information, it's likely on the low end of that. This doesn't look as dense as what it possibly could be here. So I've just, all of these names that you're seeing here are galaxies. And that's a good way to, I mean, you can go back all the way to, like, you get a nice redshift. And that's what I usually show people, is you'll see that this will go completely red if we go to the end. But there's one other thing too, and this is really cool. I think you will like this one, Dr. Pamela. This is basically our universe that you can scroll up to, looking at, you know, like our local group, or this is actually looking at our own galaxy.
Yeah.
But then go to, say, like our local group. And then you can actually go out even further, and you start to
you start to see the cluster and the Virgo supercluster.
Yeah.
And the large scale structure of the universe.
Yeah. Isn't that cool?
Awesome. And one of the cool artifacts in the image that you're showing is it looks like all the galaxies are in this bow tie arrangement in the sky. And the reason that it appears like this, and I'm telling you stuff you already know, but for our audience,
but yeah, there's people here. Yeah.
Yeah. So for our audience, the reason that this happens is our Milky Way is in there, and I'm trying to align this so that it's the can't do this so that it's the same as okay, so let's do this at a right angle. I can't. So, sorry, everything is flipped in my screen and I just can't green screen today. So, where the bow tie pinches in, our galaxy cuts through that and we can't see other galaxies on the other side of this bow tie. So, we're stuck. It's probably a spherical distribution around us and we're never going to be able to see it. We're never going to be able to see it.
Wah, wah, wah. So then we can go even closer in to systems. I don't know if it's going to even show us, because I don't think I'm even targeted on. No, I'm not. I'm on a red giant binary. It's not going to, it's fine. But if we went to our own solar system, let's see.
Very
Just go.
Star Trek in the traveling.
I know. Yeah, we were going at very high speeds there. What's really cool is you can actually map out all kinds of stuff here. You can show the orbits of the planets, which also gives good. I'm trying to talk and do this, like the dwarf planets, and you can see how much more elliptical their orbits are, which is pretty cool. So where is Pluto? Oh, Pluto's right there. There's Pluto.
Wow. And this gives you
Yeah,
that real sense of how most of the planets are well behaved and in the plane of the solar system.
yeah, the
But some of them
ecliptic.
are just like, nope, can't do it.
No,
Can't do
Pluto
it.
definitely doesn't want to. I think it's like what, 17 degrees inclined. But yeah, you can see right here, and this is also a great way to showcase the ecliptic. But yeah, you see that edge on there. But series is tilted a bit. So that's the thing. If I have to go in more to because series also
It's tilted
has
just a bit out of the
yeah,
rest of the asteroid belt. But the asteroid belt, it's more like a diffuse ring where everything scatters each other on a regular basis.
right. Yeah,
And
you see series right there.
yeah. What I love about the Bennu results is they discovered pieces of Vesta on Bennu.
Really?
Yes. So once upon a time, long, long ago, some big old rock came along, hit Vesta, made it no longer spherical, knocked off a whole bunch of chunks. Some of those chunks traveled through space, and through whatever combination of methods and pathways ended up in the rubble pile of debris that is the loosely held together asteroid Bennu, which is essentially like the garbage dumped out of the back of a gravel truck.
True. That was fun to map though. That was very interesting.
And your community over at Skynet was part of CosmoQuest's efforts to map out this world, and I ended up using one of your community members' mappings as an example at conferences because it was just like, and this is dead on from someone who asked, "Is this any good at all?" And it demonstrated. I think that was Joe who did
Yeah,
that.
yeah. With no
Um,
scientific background. And this goes to show you, this is why um, science citizen projects are amazing because sometimes, I don't know, maybe sometimes our scientific backgrounds don't do us any favors.
it's sometimes we just need to learn how to use our vision, which is better than computer vision can be right now,
Hmm.
to do tasks that we don't question too hard. And mapping other worlds is apparently one of those tasks.
Yeah, and in this game there is one thing that's pretty funny, and I think you've seen it before. But they have the Skylias cluster, so this is obviously procedural. There is no no celestial object or body or anything named after me, but they put it in here because we did raise a lot of money for the devs because they were doing this for free.
Oh, wow.
Um,
That's
and
gorgeous.
isn't that cool?
That's
Um,
super cool.
Yeah, it's really cool. And they also did something, but you would always increase, like if you're looking at any kind of nebulae,
Nebulosity.
you'd want to have that bloom because it really brings it out. But one thing that they did add in here that's pretty funny is right in the middle of it. So it's mini sky. So they put the little and wait till you see what she is.
It's a black hole.
And a fast rotating stellar mass black hole. Yeah.
Oh
So
man, that's I am not sure if that's a compliment or
I think it's great. I think it's absolutely wonderful. But you can see that lensing too. But yeah, it's about ten solar masses. But yeah, That's like really very, they have cool things in here like that are surprises and Easter eggs. But you can see I can even with the Milky Way's arm, I can lens that.
That's cool.
Yeah.
So does this have V838 Mon in it?
I'm sure it does.
Because my brain, the first thing it did when it saw the Skylias cluster was try and figure out how you end up with something that red.
What's another name for that? Because I know you're talking Monocerotis, right?
Yeah, hold on. Uh, I only know it from its variable star designation, and Wikipedia is only giving it to me. It's also known by Nova Monocerotis 2002.
Let's see if any of these names start looking, because it would be in here. But they also have a stellar, way to search for it there. I just don't know if they would. So maybe if, what was it again?
838?
And is it all combined?
Yep,
Oh,
there it
it is.
is.
That was my error. I was the one not putting it all together. I was spacing it. No
So
pun. Oh, it's
there's
the egg. This one's the title. This is an egg. This isn't a star.
eggs happen. Eggs happen. Can we zoom out and see the light echoes? So this is a system that back in 2002 let off two flashes of light. And it turns out that when a star flashes, you'll get a shell of super bright light moving away from the star. And as that shell passes through the surrounding gas and dust, you get shells of illuminated material. And so all that material that's around this was already there from when these stars underwent mass loss, from when other stars underwent mass loss. And it just took that flash, that nova, to light all of this up.
This is a hot star.
What is the weirdest thing you've randomly found while exploring our universe?
I'd say I think I actually have ran across this one before because I remember seeing this and being like, wow. Anything that's kind of got, because we're so used to seeing, the spheroidal shapes that, abide by. I mean, this one would definitely be one of those. I think one time when we looked at the mice galaxies, they don't. I don't know if they're actually no, they're going to go by their NGC. I don't remember their NGC off the top of my head. You know what also looks, and this is going to be right up your alley too, is Betelgeuse. Some people say Betelgeuse, some people say Beetlejuice.
It doesn't
Guys,
matter. And I have the
doesn't
NGC
matter.
number for the mice.
Okay, thank you. But see, look at how lumpy.
And it is like that. That's based on
Yeah.
interferometric images that we can do from here on Earth.
Yeah. And that's what makes me so excited. You could see that material being shed too.
Yeah.
But look at how lumpy it is.
It's a blob. It's a
It
blob.
is. Okay, let's look at the mice galaxies. What was the NGC?
It's 4676.
Yeah, see,
Thank
they
you,
even have it as
Morgan, for the
two.
donation, by the way.
So I have it very dim right now. But yeah, you can just see them. They used to kind of string them together a bit more,
Yeah.
but what's really cool is seeing this is one of the things I also love is seeing those dust clouds edge on too.
Yeah.
Because that's incredible when you can see like from that perspective there.
It's really kind of amazing.
Yeah, and the halos. But yeah, this one's cool. It's obviously a merger, but I imagine it's pretty hard to showcase that. But I'm sure they're going to figure stuff out like this to show more mergers. The whirlpool is also actively merging, isn't it?
Yes, but not so big.
Yeah, not like the mice. The mice were our favorite. Yeah, I mean, so this is showing the merger a bit.
That's
Yeah.
awesome. So I'm gonna pull this from the screen and have just us for a moment here.
Okay.
Now, you are another Twitch streamer, and you're here day after day bringing science to the masses in every way, shape, and form, from science to silly to including cocktails. And I'd point out
Mm-hmm.
to you that we have a couple of cocktail sessions this evening,
Yes.
one including Dr. Andy Ripkin and
Oh,
Dr. Jay Greer, and they're going to be talking about
tonight.
where in the solar system to go find the ingredients of a good drink in just reality. There's
Mm-hmm.
mixers out there, people. There's mixers out there.
That's
Um,
awesome. I didn't know that's actually happening tonight. That's amazing.
yes. So hopefully you'll go away from being a guest, but stick around to enjoy the laughter.
Oh, absolutely.
Now, where all can people find you? Because you're on Twitch, but that's not the only place people can find you.
Yeah, so I tweet, but my tweets are somewhat repetitive with every now and again some kind of other news. I usually share a lot of space news, um, but yeah, there's repetitive tweets in there. I don't share pictures of my food. So so I'm on Twitter, I am Skylias Cares. And on Twitch, just Skylias. I'm not really that great with Instagram. I just think I miss that generation, but I try. I still try.
You do
Um,
try.
I try. Taking selfies is just not something I've ever been able to feel very great about and comfortable with. Um, and I think that's mostly it. Yeah.
So
Yeah.
when is your next stream, you think?
So
And you
probably
have fires near
tonight.
you, so
Oh,
all the
yes.
caveats.
Right, right. So probably tonight, but on the weekends we typically do other stuff. So we do history, and then sometimes I might play games because if I just do science all the time, as you understand, we need
Yeah.
breaks.
Yeah.
And then throughout the week, that's when I do history or do science, do space stuff. But since also, with the schools and COVID, the beginning of my week, I used to have streams at the beginning of my week, but no longer have been able to. So I've had to reduce my working amount significantly, as a lot of people have,
Yeah.
uh, since she's here with me and I'm having to be, school mom.
Yeah.
So,
It's a lot harder to have a family right now. And kudos for finding the wherewithal, the energy, and the balance to do all the things that you do. And I'm glad you're
same to you,
around
though.
here on Twitch. All right, so we're coming up on Mines on the 49s, and you and I, we've talked about this. We need to get back into the habit of streaming more together.
Yes, absolutely.
All right. Thank you, Skylias. This has been grand.
Yes. Thank you for having me and take care, everybody. Keep looking up.
Bye bye.
All right. Bye.
And now we are going back to Mines on the 49s. We have with us Keeper of Maps, who is going to take us on a tour of, well, just what has been growing. Take it away. I can't hear you. Hold on. I may have one too few buttons clicked. Hold on. I do. I have one too few buttons clicked. Maybe? Can you hear me, Keeper?
I can hear you.
All right. So take it away, Keeper. Show us around.
Alrighty, so we've been busy in Minecraft. There's been some development outside on the overworld, but a lot of it's been in space. But I'm going to give you the quick tour of the ground. We have our launch facility, which I believe Ms. Britkitten was mostly working on early on. We have a lunar lander that Ambius worked on. I believe it's made mostly out of gold. So kind of a nice material. We have my observatory up here overlooking everything. And a few hours ago, we did in fact install the telescope. You can see it poking out there. And we just have to build the platform to observe at the back. And we had a space shuttle show up. Very nicely done space shuttle. And we have around the corner over here, we have an ever-growing library. It looks like it's had a little bit more put on since the last time I looked at it. And you can just come around here and peer in through the windows. Maybe even walk in through the door. So lots of books in our library here. And then we'll go quickly to space. We're going to teleport to the center of the sun, to our welcome center, which has now got a roof since one of the last times I was on stream showing this off. And we're out to Mercury, closest planet to the sun. And Mercury is just about done. I think there may be just a few blocks here in the back corner that we need to replace, but Mercury's looking pretty good. And back to the sun, we'll take a quick look at Venus. And Venus is coming along slowly but surely. There are a lot of planets to work on. If you want to join us in the Minecraft, you are most welcome. I'm sure that someone can drop the link to the registration form for Minecraft in the chat. Now, I saw a lot of chatter before I came on that people had started to work on Earth. And yes, we have North America and South America starting to take shape. We have oceans. We have a molten core. So this is very, very encouraging. And lots of people working on it. In fact, there's Ms. Brick Kitten. And we'll try and go to the moon without sending her to the moon instead. And the moon is basically done. One of the first bodies in the solar system to be completed, I believe, in our build. Complete with the little Israeli lander that made it to the moon, but was going a little bit too fast sideways upon landing. Oops. And so Mars. Been a little while since I checked in on Mars, but Mars is looking fabulous. You can see both of the polar caps. And this is all built in Minecraft and all built by hand. The spheres that we're building on were generated, but all of these blocks, these colored blocks, were placed by hand. And whoops, after Mars, we go sliding across the floor and we'll go to Jupiter. Jupiter is the largest planet in the solar system, the largest planet, largest object in our Minecraft universe here. It actually spans from the bottom of the universe, of our space, to the top of our space. And you can actually see, if you watch very carefully near the crosshairs, that there are blocks appearing as people who are working on the clouds or adding clouds to the to Jupiter. There we go. You can see some white lines coming in. After Jupiter, we go to Saturn. Saturn was the first thing that I looked at through my telescope when I bought it. And that's because Saturn has rings. And we'll zip up here a little bit and you can see the extent of these rings. And we've got a long way to go around this planet. And you can see that people are starting to fill in some of the detail in the clouds on Saturn. And if we go up to the top, I believe we even have the polar vortices that are at the top of Saturn. And I know Miss Brickkitten has been working on those. And our rings are being done by a team that are taking a few hours off because making rings is tiring work. But you can see that we've got stretching out in the distance the separation for all of the major rings that we're going to try and build in Minecraft. And get back to our little platform so we can push the button to go to the next place. We'll take a little peek at Titan. There's Titan. Cute little moon. And what do we have next? We have Uranus. Oh, Uranus is starting to come along. Uranus, of course, it's been knocked on its side, so its North Pole is actually 90 degrees out of position from where you would expect to find it on another planet. And you can see that people are starting to fill in the colors of Uranus, which is primarily blue. And a quick jaunt from Uranus will take us to Neptune. And we can see that indeed Neptune is starting to take shape. We've got colors coming in very nicely. And last but not least, we're going to pop out to Pluto. And I think I did most but not all of the work on Pluto, and I'm kind of proud of it. Pluto has that very distinctive heart-shaped feature on it, which we've managed to recreate in Minecraft. And other than that, we've got blues and we've got some ices going on. And I think that's where we are, Pamela. And I think people have shown on previous visits the extent of the sun.
The sun is one of my favorite things you all have put together so far. And so what all are some of the Easter eggs that you're planning to put in, or are you willing to reveal any of them yet?
We're going to have a discussion about possibly adding in our favorite stone-covered asteroid, Bennu. I think
I'm a
there's a
fan of
chance
that.
I think there's a chance that Bennu may be appearing. And Ms. Kitten says she's added the core of the Earth, which is very impressive. And I don't know what I'm going to build. There are a couple of items in memory of our good friend Paranor, who passed away about a month ago, and I think we're going to start adding those elements to the solar system as we get done on our planets. And so Kitten says, so Bennu's going to be an armor stand holding a button, and yep, pretty much. Bennu's only 500 meters across. We have to round up to get a block in Minecraft at the scale we're working at.
And that is okay. And yeah, what we're doing, this idea was Paranor 001's Tim Hawking's. He was He's the one who connected us with the 8-bit community, and we're so happy to have all of you joining us for this event. And so there will be a lot of Tim's favorite things in the solar system scattered throughout this particular build. So what is the next thing you're going to be working on, Keeper?
The next thing I'm going to work on, Mercury needs a little bit
I love the space
left.
shuttle just sitting there in the grass. That is amazing.
We've got a rocket part building up here. If I go up a little bit and I back up, I mean, you can see we've got a space shuttle, we've got a launch gantry, we've got clouds that are obscuring our lander. There it is, right in the distance, and we've got our big telescope.
That's awesome.
Yeah.
So thank you so much for joining me and bringing us the solar system in Minecraft.
We can't do it without all of our builders.
This is a community effort, and science is a community endeavor, and it's going to take all of us working alongside one another to either build the solar system in Minecraft or map it out here at CosmoQuest. This is a fundraiser. Your donations go to allowing us to keep doing everything we do, whether it be mapping the next world, may it not be as rocky as Bennu,
So many
or
rocks.
bringing you Astronomy Cast, The Daily Space, or any of the other programs that we produce. Thank you. I'm going to now switch on over to our next set of guests. Thanks, Keeper.
Thanks, Pamela.